Hello my dear students, this is Akash HD and welcome to the ASD classes. So students, I hope so you have seen the part 1 of the Coulomb's law. In that video I have talked about the Coulomb's law and the cases of forces in a vacuum, in a medium, and when the medium between the charges are partial. Now all these things we have discussed in a part 1 Coulomb's law. Now in this video students, we are going to discuss about the applications of the Coulomb's law. Because as of now we have taken only two charges, but if in case instead of two charges multiple charges are there, then in that situation we have to apply the principle of superposition, and that we are going to learn. Okay students, so let's start here. See here please, the force between multiple charges, or we can tell superposition principle. So see here, according to principle of superposition, total force on a given charge. What is there? Total force on a given charge, this one here. Total force on a given charge is the vector sum of individual forces acting on that charge due to all the charges here. Now we are going to imagine one system. Let a system contains n point charges q1, q2, q1. Then by the principle of superposition, the force on q1 due to all the other charges is given by here. Okay, so here I am going to take here please, here I have taken the, let's take here q2 is there, here q3 is there, and let's take for example here q1 is there, q2, q3, q4, q5, like this q1 is there. Okay, and here I have taken this charge q1 here. This charge q1 is there. So now what I am going to do here, we are going to find out the first the distances and all. So let's see here please, let's take this distance, this one here, and this distance, and this one is also is there. Okay, after that students, you know very well this force, electrostatic force, is the which kind of force? That is a central force here. That means we have to draw the forces acting along the line joining the charges. So please see very well, the force between q1 and q2 will be given by this here, and that is called here force on 1 due to 2, and this force will be independent of the presence of this q3 and qn. Similarly, the force between q1 and q3 will be given by like this here, and this one will be given here F13, and this force F13 is also independent of the presence of q2 and q1. Similarly, the force between q1 and qn, it will act like this here in this direction here, and I will write here F1n. And again, this force between q1 and qn is independent of q2 and q3. So here how many forces are there? You can see here the three forces are there. Okay, so now the resultant force on charge q1, resultant force on charge q1 will be the vector sum of all of them. That means what we can write here, F12, and even we can write here F13, or we can write here what, F1n, vector sum here, Okay, now after that, before going into the cases, we should remember the triangle law of vector addition, and it is similar to the parallelogram law of vector addition also, that I will just tell you here. Okay students, so what is there here, what I am telling here, I am going to just tell you here the parallelogram law here. Parallelogram law of vector addition. So let's take here I have the two vectors are there like this. Now let's take this is vector A and this is vector B. Okay, so the resultant of both these vectors will be given by the diagonal, the passing through the same intersections point here. Okay, so the magnitude of this diagonal is given by mod r equal to, what is this, a square, a square plus b square plus 2ab cos theta here. And what is this theta? Theta is the angle between vector A and vector B. And if in case this magnitudes are equal, if this magnitude mod A is equal to mod B, and I have taken, let's take A, then this resultant we can write here 2a cos theta by 2. Okay, this basic we have to use here for the further cases and all that here. So now after knowing all these basics and all that, we are going to see the cases. Okay, so let's see here one by one students here. So cases of resultant force due to multiple charges here, and here in case 1 what I have taken, three identical charges at the vertices of an equilateral triangle. So equilateral triangle means what will happen that here all these sides of the triangle will have the same length here. This L, all this. Now they will have the all same length here. After that, let's take here I have taken charge Q. Here I have taken charge Q. And let's take here also I have taken charge Q. 3 identical charges here, okay? And let me give the names also. Names. Let's take this is charge 1. Now this is charge 2 and this is charge 3 here. So now can you tell to me this charge Q at the vertices 3 will experience how many forces? It will experience, dear students, how many forces? 2 forces here, okay? So let me say here the force on 3 due to 1 will be given by like this here. This is called what? Force on 3 due to 1. Similarly, force on 3 due to 2 will be given by like this here. What is this? Force on 3 due to 2 here. Now the resultant of this. Now, so for that we have to draw here the one rough parallelogram here, and the resultant will be given by like this here, okay? So this is the resultant on 3 here. Now, so let me just draw here the values. What is the value of F31? Students here please. F31. What is the formula of the force from the Coulomb's law? 1 by 4 pi epsilon naught, that I will take K, okay? So let me write here K, Q1, Q3, and distance how much here? L. So K, Q1, Q3 by L square here. Similarly, if I write here F32, this one here, this F32, this will be how much, students? Again, K, Q2, Q3 by L square. But here what is there? The charges are having the same magnitude here. Now, so let me see it please. Q2, Q3 by L square here. Just 1 minute here. L square. But what I told, the charges are what? Identical charges are there. That means here also we can write KQ square by L square. And here also what can I write? KQ square by L square. And you can see that here these magnitude of the forces are same here. So here how much here? F. And here also how much? Students, F. Now, can you tell to me in equilateral triangle this angle how much here? 60 degree. So this angle also how much here? This angle is also 60 degree. And you can see that the magnitude of the forces is what? Same. Okay. So if we have to write here the resultant force here. So resultant force at the vertices 3 is given by what is the formula? 2F cos theta by 2. Okay. So see here please here 2F, and the theta value how much is? 60 degree. So 60 degree by 2, students, what to write here? Cos 30. And the value of cos 30 how much? Root 3 by 2. So we can write here please 2F into root 3 by 2. 2 and 2 cancel. That means I can write here this resultant force. This resultant force is going to be how much? Students, see please here root 3, and the value of F how much? This one here. Right please here KQ square by L square. This is the resultant force at the vertices 3. Similarly, at the vertices 1 and 2 also, the magnitude of the force will be what? The magnitude of the force will be same, this value. Only the directions will be different. Magnitude will be what, students? Same. After that, we are going to see the case 2. Here what is there? 4 identical charges at the vertices of a square here. So here I have taken square of side length how much here? Let's take here again L, L, L and L. And here how many charges will be having? Students, just think please. Now here this is Q, this is Q, this is Q, and here also how much? This is also Q here. And we'll give the names, numberings. Now let's take this is 1, this is 2, this is 3, and this is 4 here. Now, so now what I am going to do, I am going to find out the resultant force at the vertices 4 where charge Q is present. So here can you think how many forces will be experienced by this charge Q? Yes, how many forces? 3 forces here, okay? So see here please here, the force on 4 due to 1 will be in this direction. We can tell here what is this? F41. Similarly, force on 4 due to 3 will be in which direction here? This direction. We can take here F43. Similarly, the force on 4 due to 2, again we have to draw here this one. Here please here. We have to connect them by the straight line because the forces are central forces here, and that will be given here how much here? Just so see here please, this will be given by like this here, and this force will be what? This force will be F force on 4 due to 2 here. So how many forces are there here? Students, there are 3 forces are there. So now we have to find out the resultant of how many forces? 3 forces. So we know very well here the resultant force on 4 is given here F41 plus F42 plus F43. Is it? But here you can see that here we want to find out the resultant. So if you will see that here the angle between F41 and F43, how much here? 90 degree. That means resultant of these two forces will be easy. That means what we are going to do? First we are going to find out the resultant of these two forces. Then that resultant we are going to add with the force F42. That means we can see from here, first we are going to find out the resultant of F41 and F43. Let's take, I will write this F4 dash. F4 dash, and that resultant I am going to add with the F42 here. Okay, that basic we are going to use here. So let's start one by one. So here students, if I write here the value of F41 and F43, what will happen there students? Both these values will be equal. How much? KQ square by distance between the 4 and 1 and 4 and 3, how much here? In both these situations, L. That means we can write here KQ square by L square. Similarly, if I want to find out this F42, so F42 will be what here? Students, see please here, F42, it will be given here KQ square by, this is L, that means this length how much here? L root 2, and we'll write here L root 2 square, that means it will become here KQ square by 2L square. And if we are taking this as F, then this will be how much? Students, this is going to be F by 2. Now our forces are ready. Now what we are going to find out? We are going to find out the resultant of which one? F41 and F43. Okay, so resultant of students F41 and F43. How much angle is there? 90 degree angle is there. Okay, students. So just let me write here this F4 dash. F4 dash will be how much here? Let me write here 2F cos theta by 2. Now, so the F41 and F43 is making how much angle? 90 degree here. So it will become here, students here, please here, 2F cos 45 degree here. That means how much coming here? 2F cos 45 value 1 by root 2. That means it is coming here what? It will coming here root 2F here. Okay, this is what? This is F4 dash. Now, and where is this F4 dash? This F4 dash, students, we can just draw here. See, please see this here. Now, see, this is the F4 dash. This is the F4 dash here. Now you can see very well F4 dash and F42 in which direction? Same direction. That means angle between these two vectors how much here? 0 degree here. Okay, so now we are going to find out the resultant between F4 dash and F42. F4 dash already we have got the value, and F4 2 value how much? F by 2. Now that we are going to use here. So see the students here. Now again resultant. Now see resultant of F4 dash and F42 is both in the same direction. That means we can write here F4 equal to F4 dash plus F42. What is the value of the F4 dash? Students, see please, root 3 into F, and F42 value how much here? F by 2. So F is common, so we can write here root 2 plus 1 by 2. And what is the value of F? The value of F is this one here, na? KQ square by L square. So that value I am just going to put here. That means resultant F4 will come how much here? Just see please, root 2 plus 1 by 2 F value KQ square by L square. This is the resultant force on charge. Where? On charge this Q at the vertices number 4. Similarly, at the vertices number 3, 2, 1, the magnitude of the forces will be what? The magnitude of the forces will be same. Okay, only the directions will be opposite here. To get the directions, we have to use the unity rule method, or we can get by the projection of the vectors also along x direction, y direction, and all that. Now, that is the very basic. I hope so you know very well here. Okay, students. So let's after that move to the next one here. See please here now. Case 3, non-identical charges at the vertices of an equilateral triangle and a square. So see here please here, non-identical charges. So let's take here Q, and let's take here I have taken minus Q. Then what will happen in this situation? This kind of questions can be solved very easily. How? By drawing the what? By drawing the identical, or we can tell equivalent diagram here. Okay, so I will come to this case, but before that I will just tell you one more case is there. No? Then I will return back to this case here. No? First we have to learn this actually here. No? Then we'll go to that case here. See here please here. cases of equilibrium of the multiple charges are here. Okay, equilibrium. So students, what is the meaning of the equilibrium? Equilibrium means what? The net force on the charge is 0. Okay, so see here, please here. Equilibrium of a charged particle Q0 at the center of symmetrical geometrical point charge system here. So students, here I am going to take some charges here. Now let's take here charge Q, here charge Q, here charge Q, and here also charge Q is there. Okay, and at the center I am going to put the charge Q0. Can you guess this charge Q0 will experience how many forces? It will experience 4 forces here, yes or no? But what will happen that here all these forces will cancel out. See please here, the force between Q and Q0 in which direction? This direction. Similarly, force between this Q and Q0 in which direction? This direction. This Q and Q0 in which direction? This direction. This Q and Q0 in which direction? This direction. That means all these forces will cancel out. That means resultant force on charge Q0 will be how much here? 0. That means whenever a charge is placed at the centroid, at the center about this symmetrical charge distribution, then force will be how much? 0. Similarly, here also see please here Q, and here also I have taken Q here. And let's take here at the geometrical center, I have taken how much charge? Q0 is there. Then again, how many forces will be there? 3 forces. And again, all these forces will cancel out here. Let's take here again. Let me draw here. Let's take the force between Q and Q0 in which direction? This one here. Q and Q0 in which direction? This direction. And this Q and Q0 in which direction? This direction. All these forces will be equal. Okay, and they will make how much angle? 120 degree from each other. That means here also resultant force on the charge Q0 how much here? 0 here. Here also the forces will be same only here. Okay, so this concept we are going to use for the previous situation is there. Okay, so let's see here please. What I told here now, see this Q minus Q. So what I will write here, this minus Q, I will just write here Q minus 2Q. What is there? I will write here how much here? Q minus 2Q here. Is it? So let's take for example here, if I have the force like this here, question will come like this here. No? And here one charge I put Q0. Then this charge Q0 will experience how much forces here? Think please students, do you think the force on the Q0 will be 0? No. Why? Because this charge distribution is not uniform. Q minus Q is there. That means what will happen that here? Think please. See here. Due to this Q and this due to this Q, resultant force on Q0 will be how much here? It will be 0. Then how much force will be left here? See please, how much is there? Here how much left? This Q went. That means how much left here? Minus 2Q. Here minus 2Q left, and here how much left here? Here the charge Q0 is left. And can you get please, in case of the triangle, the length will be how much? This length? Students, see here please. If this is L, then students, this length is used to be L by root 3. This length is used to be how much here? L by root 3. Now can we get the force? Which force will be there? Attractive force will be there. And the value of the force will be how much here between them? This force. Now we are just going to find out the force here. So this force here, this force will be how much here? See please here. K 2Q into Q0, only magnitude, by L by root 3 whole square. Okay, so this will be the force experienced by this charge Q0 placed at the centroid. Okay, next one is after that here. Students, here also I have taken how many charges will be there? 4 charges will be there. Here also same story. Q, and let's take here it is given Q, and here it is given how much here? Minus Q. Same, what we will do students here, even any kind of charge they may give here, basic will be same here. So again, this minus Q I will write here Q minus 2Q. So force due to Q, and this due to Q at the centroid will be how much here? At the centroid will be how much here? 0. Okay, that means which charge will be left here? Only this minus 2Q charge will be left here. Okay, so let me draw here the equivalent diagram students here. Now equivalent diagram. So see please, how much charge is left here? Here the charge is left minus 2Q, and at the centroid how much charge is there? Q0 here. Again, this length used to be how much here? If this is L, then this length is used to be how much students? L by root 2, that you know very well from the Pythagoras theorem. Is it? That means again, this charge Q0 will experience force in this direction here. Okay, and this force F is given by, think please, K Q0, and here 2Q, and the distance between the charges how much here? L by root 2 square here. Okay, so this much force will be experienced by the charges. Okay, clear? Yes. So now after that we have seen, students, you can see how many cases we have seen, multiple cases we have seen that. Now after that, for the equilibrium only, we are going to see this case 2 here. So see here please here, equilibrium of a charge Q0 between two like charges Q1 and Q0 here. Okay, so see here please here charge Q1 is there, Q1, and here charge students Q2 is there. Now, and I am going to put what? I am going to put one third charge in between them here. Okay, let's see here. This charge is Q0 here, and let's take this distance I have taken D. Okay, and I am going to find out what is the distance of the charge Q0 so that this charge should be in a equilibrium here. Okay, so let's take here this distance. How much, students? This distance. This distance I have taken x here. Okay, so this distance will be how much here? This distance will be d minus x. Okay, now you think please, this charge Q0 will experience how many forces? Two forces here. And from the principle of superposition, how many forces, students? Two forces. So the force between Q1 and Q0 in which direction? This direction here. That I will write here F01. Similarly, force on Q0 due to Q2 in which direction? This direction here. And what will be this, students? Think please, F02. And you know very well, if the charge this Q0 in equilibrium, that means net force will be how much? Net force will be 0. That means both these forces are what? Balanced here. Okay, because we are learning what? Equilibrium. Both the forces will be balanced here. So see here please here. For the balancing of the forces, what will happen? This F01 will be equal to F02. What is the value of the F01? Just write please here. K Q1 Q0 by x square. Similarly, F02 value how much here? K Q2 Q0 by distance between them how much here, students? See, d minus x whole square. Then what will happen, students? This Q0 and this Q0 will cancel out. And when you will find out the value of x, it will come d by root Q2 by Q1 plus 1. Okay, this is the value here. And please make sure that this value of x is from which charge? From the smaller charge. From which charge? Smaller charge here. This charge should be smaller charge here. Please make sure that, otherwise mistake will happen. Smaller charge here. Magnitude wise, that means this mod Q1 should be less than mod Q2. Please remember that from the smaller charge. Okay. Next one is, students, here. See here please. Again now. Next case, case 3, equilibrium of charge Q0 between two unlike charges Q1 and minus Q2. Which charges? Unlike charges, students. So see here please here. This is Q1 and this one minus Q2. So what will happen that if we keep the charge Q0 in between the charges, then there what will happen that the net force will not be 0 here. Think please here. Let's take, I put charge Q0 here. So Q1 and Q0 repel, minus Q2 and Q0 unlike charges, they will attract. That means here equilibrium situation cannot be achieved. That means what we have to do? We have to keep the charges outside between the charges here. Okay, so see here please here. I will take the charge somewhere here. Now here charge is there. Here I have taken charge Q0 is there. Okay, students. So let's take here again. This distance how much here? This distance is R, and this distance I have taken x here. Okay, so again let's draw the forces, students. What are the forces will be there? Force on Q0 due to Q1. In which direction? Repulsive force here. So F01. Similarly, force between Q0 and minus Q2. Which force? Attractive force. That means in which direction? This direction here. And I will write here F02. Again, students, for the equilibrium of the charges, what will happen? Both these forces should be balanced here. So see here please again, students. This F01 should be equal to F02. And what is the value of the F01? Q1, Q0 and this distance x. That means right here. K Q1 Q0 by x square is equal to, what you write here? Force between Q2 and Q0. That means here K Q2 Q0. Distance between Q2 and Q0 how much here? X plus this R here. Now x plus R here. X plus R whole square here. Now just let me. Previous situation here I have taken D, and in next situation I have taken R. Anything can be given according to the question. We have to take it here. So what will happen that here? This Q0 and Q0 will cancel out, and this K and K will also, students, cancel out here. Okay. So when you will simplify this value of x will come here R by root Q2 by Q1 minus 1 here. Okay. Previous plus 1, but this time minus 1. And again this x distance is from which charge? From the smaller charge here, magnitude wise. This x distance is from where? From the smaller charge here. Okay, and here I am taking this Q1 is the smaller charge here. That means again mod Q1 is less than mod Q2. Now magnitude of the charges here. Let's take for example here I have given charge minus 1 coulomb and 2 coulomb here. Which charge is the smaller? Which charge is the smaller? Magnitude wise, you have to just see the magnitude. -1 and 2, which one is smaller? This -1 is smaller here. Okay, 1 is smaller than 2. Okay, only the magnitude here. Please remember that very well. Okay, students. Next one, please. Here, please. Now, case 4, equilibrium of symmetrical geometrical point charges system for the equilateral triangle and square. Okay, so here students, this kind of questions comes very common in exam. Let's take what is here. Here charge q is there, here charge q is there, and here also charge q is there. Okay, and let's take what is there at this geometrical center. We have put charge capital Q. So here what will happen, that students, in the question they will ask that full system in equilibrium. We know very well this charge capital Q in equilibrium, that we have seen. But what about this charge Q, Q and Q? In the previous situations, those charge Q was fixed. But now here what is happening? These charges are not fixed. Then what we have to do here? As we know the capital Q in equilibrium, but small q also we have to make it a equilibrium. So see here, please here. Due to charge this q and this q, force will be how much here? We know very well. This force how much, students, here? √3 kq square by L square, that we know very well here. Okay, but what about the charge capital Q and small q? If in the question they did not mention anything, that means what we'll consider? We will consider this charge. We are just considering this charge is what? Positive. That means the force between capital Q and small q also in which direction? I am just considering that in this direction. I know for the resultant force both this should be cancelled out here, no? But I am just considering here. Okay, so if this is L, this is L, this is L, this length how much L? L by √3. So let's do here the force on Q going to be how much here? 0. Let's do here, please here. So we'll write here this value how much here? See please, √3 kq square by L square plus the force between capital Q and small q how much here? See please, k capital Q small q by distance between small q and capital Q how much here? L by √3 whole square is equal to 0. So after that, after solving and all, when you will get the value of capital Q, it will come here minus q by √3. That means by the calculation we are getting that this charge should be what? This charge should be negative. Now technically we was knowing it was negative, but we have just considered that. We was considering, let's take, we don't know which kind of charge is there, so we have taken which charge? Positive charge. Similarly, last case you can see here how many charges will be there? 4 charges will be there, and again it will be the equilibrium here. Q, 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 and here also Q here. Okay, so let's take here like this. Now like this here, and here I have taken charge capital Q. Again you know very well the net force on the charge capital Q how much? 0. But what we are going to do to make all the 5 charges in equilibrium, what will happen? The force on this small q also should be how much? 0. So let's take here, please here. Again this length L, this length L, this length L, this length N. Then this length going to be how much here? L by √2. And you know very well the force on this small q due to rest of the 3 charges how much here? In this direction. And what was the value? The value was, if you remember, √2 plus 1 by 2 kq square by L square here. Okay, now after that what will happen? That here if I take the force between small q and capital Q here, again I am considering that this capital Q is the positive here. Now so what is there? Let's take force in this direction. I am just considering simply. So this force will be how much here? Let's take here k capital Q small q. Distance between them how much here? L by √2 square. So what is there? The net force should be 0. That means force on charge Q should be how much here? 0 here. Okay, so again we will just write here. See please, we'll just write here √2 plus 1 by 2 kq square by L square plus this k capital Q L by √2 whole square equal to how much here? 0. And after that, students, when you will simplify this and all that, what will come here? This capital Q value will come minus q 1 plus 2 √2 by 4. Okay, so please remember that here if we want that all these 4 charges should be in a equilibrium, that means this capital Q charge should be how much? This should be what? This should be negative. Please remember that very well here. Okay, okay. So students, just please check this value after the calculation. I think so in most of the case this value will match here. Okay students, so in today's class we have learned about the application of the Coulomb's law. If you have understood this video very well, just comment, share and subscribe to my channel. Thank you so much.